let's say that we're going from 44 millimeters and we want to find out how many meters are in that. The very first step on all of these problems is write down what you know, and then you look to see what label you need to cancel out. And the label we're looking to cancel out here is mm. Okay, so I'm going to put that on bottom because I know if I divide mm by mm, it's going to cancel out. Now I want to look to the relationship between the prefix and the base, because that's what I'm going for, is the base here. And I always want to touch base for the first step. So I'm going to put that label right now so I know that the number that is with the base is in the correct position in order for this label to be canceled out, since I don't want that. So I find mm, here's the prefix. I find mm has 1 times 10 to the third associated with it. Now this base could be any base. For our use this time, it's going to be meters. So we'll go back to our problem, and we can say that for every 1 millimeter, we have 1 times 10 to the negative third meters. And then we can see that this cancels out. And then it's time to do our calculations, because we're left with the label that we're looking for. So now we can actually do the math. Okay, I have my scientific calculator up here, and this button right here, oops, I just lost my calculator. So the button EXP, so it's right here, that button right there, EXP, means times 10, and it waits for you to put in a power. You might have just a capital letter EE on your calculator. That will mean the same thing. So I'm just going to write that up here so you look for the right button. EE, and it could be second function, or EXP. These buttons are the most common. Another one might be times 10 and has a little dash up here. All of these 3 buttons mean the same thing. And what they do is they mean times 10, and they wait for you to put in the power that you want to indicate. So if you have a number before the times 10, which we do, our number is 1, you have to put that in first. So I'll bring up that calculator and I'll show you how to push the buttons to be successful with this. So we look to see our first number is 44, so you push 44, and then since the number we're calculating is on top of the fraction line, you push times. If it would be on bottom, you would push divided by. And then you put in 1. And then you push your EXP button, which puts in times 10. And then you push negative button, 3. And you can push equals then and get your answer. And that is the correct answer for this problem. 0.044 meters is the correct answer. Okay, let's try another one. Let's say that we're going from 20 liters. Okay, that's the base now. We're trying to find out centiliters. Okay, so step 1, you start with 20 liters. You go to your first factor, and you realize that you have to get liters on bottom, so factors that out. And centiliters then is going to be on top here. Okay, so the question is 1 centiliter is how many liters? So you go to your tool and you find centi, okay? So I see centi right here. Here's centi, here's a little c, and that is, for 1 centiliter, it's equal to 1 times 10 to the negative second liters. So I go back over to this, and I've got 1 times 10 to the negative second liters is equal to 1 centiliter. We see the label cancels out, which is why we call it the factor out the label method. We're left with centiliter label, which is what we're looking for. So now we have to put this in our calculator. Notice, and this troubles kids. They seem to think that the number has to either go on top or on bottom. It can go either place. The thing is, the number has to go with the base. If you're following that table, the number always goes with the base. So let's look to see how we would calculate this. Okay, and we have 20, so I push 20. And then now the number's on bottom, so I have to push divide. And then I put in 1 exp negative 2, and I get an answer of 2,000. Okay, and that is the correct answer. So it's 2,000 centiliters. Okay, so once you get a hang of that, I'll show you a two-step problem. And the two-step problem is when the base isn't in the question. So let's just say we're going from 20 milliliters. Okay, so I've changed that. 20 milliliters to centiliters. Okay, so there's no base in here. Liter would be the base, but it's not by itself. So now we have a two-step problem. Start the same way, and you put milliliters on bottom because that's dictated in order to cancel that out. And 1 milliliter is equal to 1 times 10 to the negative third liters. And I can see that gets canceled out. Now liters isn't what I'm going for, so I have to cancel out this. Now I have to cancel out this label, so liters has to go on bottom. And I'm going for centiliters, and I know that 1 centiliter is 1 times 10 to the negative second liters. And now I can see that I've canceled out my liter label, and I'm left with my centiliter label, which is what I'm going for. So now I do the math with this, and I can see that I push 20. I go to my first number, it's times, because it's on top, times 1 exp negative 3, and I push equals. Okay, so I'm done with that part, and now I go to my next number, and that number is on bottom, so I'm going to have to divide with the calculator. Okay, so I divide by 1 exp negative 2, and I get my final answer of 2. Okay, so 2 centiliters is the correct answer, and that's how you do a two-step problem. Like I said, there's an easier way to do this, but if you don't do it in the factor label method, you won't get the credit for the homework because this is what I'm teaching, not getting the right answer at this time. Hopefully this helps. Have a good day.